All right, good morning and welcome to our webinar, How to Flip Your Test Automation Pyramid for Agile. My name is Sarah Lynn Bruner and I will be your host for today. And today's presenters are Thomas Stockar, Product Manager over at Tricentis, and Siva Kumar Anna, Senior Director of Enterprise QA at InfoStretch. And a little quick background on both. Thomas is currently Product Manager at Tricentis. He is mainly responsible for distributed execution, continuous integration, and the automation platform. Prior to his current role, Thomas has been working directly on the Tricentis Tosca test suite as a lead engineer. Thomas studied business informatics at the Vienna University and has over 10 years of experience of software development and over 3 years experience of Agile product ownership. And Siva Kumar Anna. As a Senior Director of Enterprise QA at InfoStretch, Siva Anna has more than 20 years of experience developing and managing QA strategies for Fortune 500 companies. In 12 years with InfoStretch, Mr. Anna has been instrumental in leading strategic enterprise engagements, which has resulted in significant value for clients such as Kaiser Permanente, The Body Shop, and Minted.com. And before we begin, let me review some housekeeping items. So first, this webcast is being recorded and will be distributed via email to you, allowing you to share it with your internal teams or to watch it again for later. Second, your line is currently muted. And third, please feel free to submit any questions during the call just by accessing the Q&A button, the navigation in the top center of your screen. We will answer all questions towards the end of the presentation. And lastly, we will do our best to keep this webinar to the 45-minute time allotment. And at this time, I'd like to hand the presentation over to our first speaker, Siva.
Thank you, Sarah. Good morning. Good morning, everyone. So let me quickly go over the agenda. So like you see, right, so I'll be kind of sharing the session with Thomas from Tricentis. So we'll be kind of splitting the agenda. So I'll be kind of covering to begin with what I see as with the experience that I have working with multiple enterprises. What I see there's a quality engineering workflow, what kind of changes. Then the last couple of bullet points would be covered by Thomas. Right. So moving along, right? So before I go into the specifics of what is the interest for today's topic about the test pyramid, how do you achieve and what are the benefits, I want to kind of lay down what I have seen with enterprises, right? What are some of the success factors that become so important in today's quality engineering, right? So the first, I'll kind of touch upon 2-3 aspects, but what you see in the screen are the top reasons or the success factors for successful quality engineering, right? The first one is about the shift left and BDD, right? So with the time to market crunch has become so important in any business. We have seen the shift left or the TDD or BDD has become one of the key elements that you need to adopt to make your overall quality engineering very successful. Right. So there are like a lot of tools and technologies available that supports or enables you to do the automation, kind of what we call it as a lead with automation or in sprint automation, right? So you want to write your test automation to begin with before even the application or the component that you are about to test is available, right? So I'll as I continue going through the other slides, you will see how we can leverage the automation, how you can do the automation much closer to the code. But what you see, the test automation or the in-sprint automation is one of the key things, right? And a couple of other things, as you might have seen in the screen, the DevOps integration has become one of the key things. With the DevOps integration, it means that you want to start your automation very early in the cycle and you want to do automation at all different layers, right? So the integration with the DevOps and continuous integration is one of the key success factors for your quality engineering. And the service virtualization has become one of the key things. I think Thomas would touch upon how you can leverage the service virtualization to do the various layered approach, which is the primary objective of today's session. You will see that service virtualization will play a critical role in enabling the pyramid approach that we recommend for the quality engineering. right? So moving along. So another key thing that we see working with many enterprises and many of the organization, the quality engineering workflow, right? It has multiple views, and what we see is the design view, execution view, analysis view, right? So what you can see from design view to all the way to the analysis view, there is a lot of enhancements and a lot of discovery has happened to enable that you are able to do the right test design from each, focusing on different aspects, right? For example, right from the test process all the way to the visual validation that you want to do for your application, because there are applications having all kind of testing interface. You want to make sure that during the design itself that has been taken into consideration, each of the interface you are able to test, and the important aspect here is that you want to start your testing very early in the cycle, and you want to state it at the code level as much as possible, and you want to kind of minimize your validation to the end-to-end cycle, right? So in the execution flow is where we kind of see a lot of innovation has happened, and we continue to see the adoption of cloud, and there is the multi-channel execution that is happening in the industry, right? And the last but not least, the analysis view also is like where some of the greatest improvements have happened over the years, recent years, in terms of the machine learning and the analytics improvement that has happened, that continuously feed that information back to the design view, right? So it is a continuous cycle. What we kind of design today, it needs to be optimized over and again as we continue to learn from the execution and the analysis tools that are available in the market. Right. Just to kind of recap on what I talked about in the couple of slides, right? So the DevOps has become one of the key things, right? So working with top 1,000 Fortune 100 companies, Fortune 1,000 companies, we see that the frequency is one of the key things that they want to increase, because the time to market has become one of the top priority for many organizations, right? To achieve that, DevOps has become as one of the key things, and also the layered automation approach is one of the enablers to achieve the DevOps movement that we are seeing in the industry. Okay. The another concept that I've seen in the recent past is with many of the enterprises. There is a big movement that is happening, and this was also mentioned in the recent World Quality Report. There is the movement that is happening from testing center of excellence to kind of a concept called center of quality engineering, or test excellence center, right? So what it means is there is a centralized responsibility or centralized authority. What it was before, all kind of focused in one centralized organization, that is kind of slowly shifting away, that each of the group can decide in terms of how they want to execute it, or what level of testing that they want to do, right? It doesn't mean that the centralized body is going away, but the responsibility is kind of shrinked, and the centralized body, the test center of excellence, is more focusing on providing the best practices, or kind of act as the tool repository. They kind of identify, continuously evaluate various tools and technologies, and provide the guidance to the actual team that is working on the project. Along with that, they provide the what I call it as more of a guidance, or kind of more of a governance, but at the end of the day, the individual project team is responsible to execute or enable what level of automation that they want to do, right? Whether it is automation at each different layer, or they want to execute ad hoc way. All that is designed at each of the test center of excellence, right? So that's a big shift that is happening. It is all because of Agile that has kind of taken over the years. So there is so much of enterprises are kind of moving from waterfall to Agile, and some of these concepts are kind of enabling to achieve the waterfall to Agile transformation that is happening in the quality engineering aspect. Right? So this is one of the critical slide, and this is the primary focus for today's topic that we are talking about, right? So this slide kind of highlights 2 or 3 points. Let me kind of take one by one, right? So as you can see in the layered automation pyramid, what we call it as the right pyramid for quality engineering, right? As you can see, what it kind of indicating is that you want to have more automation should be closer to the code, right? Which is basically the unit test. So indirectly, it is indicating that you want to have as much as possible a test automation towards the unit test, right? And it's kind of slowly going from bottom to top. And what it means is the visual test you want to have, or the end-to-end test automation, to be somewhat limited, but the more automation should be at the unit test, component test, and the integration test, right? So, and also by achieving this, right, though it is kind of a age-old concept, but a lot of tools and frameworks have kind of enabled automation to achieve using one framework, right? And definitely Thomas would talk about how Tricentis achieves this kind of a pyramid structure and how the tool is enabling you to do automation at various layers, right? So the other benefit that you get is basically the test execution, right? So as you're probably aware, the unit test or the component test, which is basically what we call it the headless test, right, is much efficient in execution as well as less dependent on the components, right? So it goes more higher, the dependencies are increasing, and the test execution becomes slower. So you want to make sure that in your strategy you have in your approach that you are putting more automation towards the bottom of the triangle compared to the top of the triangle, right? So I kind of listed some of the business benefits. What you see here is this pyramid also allows you to do the in-sprint automation. You can do the root cause analysis as quickly as possible, because when certain test cases fail, you know exactly where the failure is, and you know where the problem could be, right? So this also allows you to do a lot of automated test generation. We have seen many tools available to generate automated test scenarios at unit test, at the component test, integration test, and nowadays there are tools available to generate even at the visual test as well as GUI test, right? So with this, Sarah, I'll probably hand it over to you.
Yeah, great. Thanks so much, Siva. I would like to turn the presentation over to our next speaker, Thomas Stalker.
Hi, thanks, Sarah. Thanks, Siva. Siva just presented the test pyramid it should look like based on a stable foundation. But actually, what we see as of today is that the majority of testing effort still goes into testing, making up half of the testing budget or more. And Siva already mentioned the drawbacks, such as end-to-end tests require a fully functional system landscape, and providing these systems on compatible versions in a test environment is a huge challenge. What's more, they are very costly and time-consuming. Compared to tests on the integration level, they are about 4 times as expensive and take up 5 to 10 times as long. And the state of the system under test is checked at a very late stage, which leads to the issue that we find problems very late in the process. So bottom line, the test pyramid as it is now, standing on its head, makes up for a pretty unstable geometric body. So the consequence of these downsides, we should now try to detect errors on the lowest possible test stage. So the question that stays is now, how can we invert this upside down test pyramid to get to that point? And I want to share with you 3 key points we at Tricentis think are very important to do so. All right, let's start with the first and probably most important step from our point of view, which is to design your test cases and determine the ones you truly need. I mean, that's a no-brainer, you might say. Agreed. But what we see on average, that there is a redundancy of around 60% in test case portfolios, and even though the coverage of the business risk rarely exceeds 50%. So what we provide is our optimized functionality, and this optimized functionality can help you in overcoming that, that issue. All right, so let me quickly reflect on the situation we have to deal with. With the increasing amount of tests we run, we hopefully also can increase the level of coverage. That's why we continuously add tests if they make sense. So if we improve our product, have new features, we probably introduce new regression tests for that. But at some point, we will reach a critical limit where adding new tests to our portfolio will not make any more sense for several reasons, such as, let's say, time or budget constraints. So the time and budget needed to exhaustively test all possible situations is pretty much infinite, which is why we have to take a decision on what to focus on. As a rule of thumb, of course, there's the 20-80 rule. With around 20% of the right test cases, you can already cover around 80% of your risk. And Tricentis Tosca's optimized capabilities now support you here to find exactly the right test cases you really should focus on. So Tosca test case design is the first thing I want to talk about. That's part of the optimized capabilities. It enables you to put your test cases into a logical structure with test sheets that allow you to create all combinations of possible test cases that are required to ensure the desired test coverage. And with equivalence classes, they serve as a starting point for reducing the number of test cases. And the final test sheet is then assigned to the test case template so that all required test cases are instantiated for execution with only a single click. I've prepared an example here, so let's quickly go through that easy example to explain it. Let's say your system under test is supposed to cook spaghettis al dente. To achieve this, it requires certain preconditions, such as you have to have these raw spaghettis, and you have to execute a certain amount of actions to get your spaghetti al dente, such as you need to boil water. Test case design now allows you to describe this process and decide on what is really necessary and what has to be verified against. Therefore, we use the concept of the straight-through, which is basically nothing else than a happy path, so actions that definitely will lead to the desired result when executed properly. And based on this straight-through now, we adapt one parameter at a time until we reach the maximum coverage possible. And this all happens at one central place and can be populated into hundreds of test cases afterwards with a single click. With this approach, Tricentis Tosca will keep you the overall amount of test cases low while maxing out your test coverage. This logic will help you to be faster and more consistent when building up your test case specification. And of course, it comes with some other benefits, such as it gives you the possibility to really focus on business risk instead of simply the number of test cases. What's more, you can achieve a substantial reduction of the overall number of test cases, and especially removing redundant tests. And last but not least, you have a heavily reduced maintenance. Why? Because you have everything at a central place, a central test sheet where, that you can maintain your combinations, and with one single click, you can now instantiate the test cases. Even if something changes, you simply instantiate them once again. So that was the first step, design your test cases. But of course, completely avoiding end-to-end tests is definitely not an option. We know that. Though end-to-end test cases can be reduced to a minimum, and that's what we strive for. With a simulation or virtualization of the connected systems, it's possible to reduce the complexity of complex system landscapes, and therefore we can physically decouple and break them up into standalone systems, still working as if they were fully connected with the landscape. That's what virtualization is basically about. And with this approach, tests that had to be previously conducted in end-to-end tests can now be treated as system internal tests, so to say. Let's have a closer look at the situation we have to deal with. Here is a representation of a disease gene network. And you know what? A typical enterprise system landscape is pretty similar to that. Your target application is not a standalone app, so you can use for processing data, but rather a part of a whole environment connected to dozens of additional applications, consuming several services, and so on. And this leads to the fact that on average, more than 30 different systems are required to be up and running for development and testing. And guess what? Most of the time, they are not. So some may currently be offline, others may be still don't exist, or they are currently built, developed. So if you're in this situation, it's simply impossible to sustainably run your end-to-end tests. And from a testing perspective, you could say, welcome to testers hell in that case. But of course, there's a cure. Our newest member of the Tricentis family, which is called Tricentis Orchestrated Service Virtualization, provides the most modern technology to decouple such systems for development and test purposes. So customers can decide on the level of each business scenario, which system they want to physically integrate in the test and which ones to simulate. So far, many customers hesitated to adopt the benefits of service virtualization in general. Why? Well, because it appeared as a very technical task in the past, requiring programmers to set up the virtualization and to run it. But we at Tricentis try to overcome that issue. We try to lift service virtualization up to the business level, making business testers productive who have no programming skills. Here's an example. Let's say you have the test driver on the left-hand side, as you can see here, and your target application in the middle, and the required additional systems on the right. You got several systems your environment has to talk with. And Tricentis Orchestrated Service Virtualization now lets you record these systems to simulate them afterwards in absence of the actual system, so that during your test execution, your application is communicating with orchestrated service virtualization only. So how will this support you in shifting testing to the left, you might ask? Well, I have a simple example. I would like to explain this with the symphony orchestra example. Let's say you're playing an orchestra, you're playing a certain instrument, but before practicing with the whole orchestra, you will probably practice alone at home and probably mock the rest of the orchestra with a recording, for example. Next time you meet others to practice the direct interaction. And finally, at the end, you go for the real rehearsal. And the same is true for testing. OSV now enables you to replace parts of your orchestra with recordings to be able to focus testing on a certain piece of your application. We often refer here to the approach as divide and conquer, so to say. So each team can now cut out dependencies and focus on its product only. There are several development teams. They are producing several parts of your product, and they do their testing within their sprints. And the goal is to make them independent, at least in certain testing stages from the rest of the environment. This provides you a tool for isolated component testing earlier within the delivery cycle, and therefore you get earlier feedback and better quality before you move on to the next stage. So let me show how this could look like. Let's say you are still in development of your application. Most dependent systems are not yet available, possible still in development as well. And by using Task OSV, you now can remove the dependencies to still be able to run your tests towards your product. In the next stage, the integration testing phase, you add one or several environments and test the interaction between them. But your product is already fairly well tested at that stage and has a way better quality, which is why you can, in that phase, really focus on integration tests only. Now we enter the user acceptance phase, where all components now interact with each other. the number of tests you now have to run can be massively reduced as you already enter this stage with a certain confidence that the quality of your system is acceptable. And finally, there may be an additional production stage where you run now your end-to-end tests against the whole system to make sure your product works as expected in the production-like environment. And that's basically it. So what does it mean in numbers? I've got a chart here for you. Following the approach of the upside-down testing pyramid we talked about initially, the distribution of defects discovered per test phase looks something like the black parts of the chart we see here. So the majority of defects is found in integration phase, but still system and acceptance tests reveal a fairly high number of defects. Having successfully implemented Tricentis OSV now leads to the substantial shift of these numbers to at least one phase to the left. And that's important, that's crucial. Shifting or discovering the vast majority of the issues at least one phase earlier saves you a lot of money. And it's remarkable that the cost of finding defects increases with every test phase. So it lets you reduce the average cost of a defect by almost 40%, which is really remarkable. So these were the first two items. One is left. We have talked about designing our tests to reduce redundancies and focus on business risk, and we have presented the possibility to shift left testing via Tricentis orchestrated service virtualization. One last thing I'd like to propose for successfully flipping the test pyramid is to use the closest access to the tested logic. So what do I mean with that? If we have a look at today's distribution of testing approaches, we see that still a vast majority of tests are done manually. A small part, which is covered by automated tests, still mainly focuses on UI tests. But guess what? This will change. We already see that it's already changing. The reason why automation rates are that low is automation with most tools at the moment requires developers. But guess what? It does not with Tricentis Pascal. What we have seen is that automation rates will increase dramatically, up to 80 or 90% even. And what is most significant here is the fact that the majority will be API-based tests, which brings me to the initial statement. API testing uses the closest access to the tested logic. So instead of going through an additional abstraction layer, such as the UI, we directly run our tests on the service layer. That's the basic idea of it. So there are strong arguments why you should focus on API testing instead of UI. Let's say this is a typical sprint timeline. As we can see, the UI is, and I can refer to that as really to be true as a product manager. I see this on a daily basis. As we can see, the UI is very likely to change throughout the development process. And just right at the end of our sprint, the UI will get its final look and feel. And this makes testing almost impossible throughout our sprint and shifts it to the very end with the risk of failing without having the chance to adapt our product in time. APIs, on the other hand, are pretty stable right from the start and will change only slightly over time. This makes it the perfect candidate for early and progressive testing. Besides that, API tests can be created way faster than UI tests, as you do not have to take care of UI synchronization or difficult environment setups. And what's more, it can run in a fraction of the time required for UI tests. All right. So here is a typical, let's have a look what a test case looks like in Tricentis Tosca. Here's a typical UI test that would look like in Tricentis Tosca on the left-hand side and the corresponding application on the right-hand side. As you can see, they look pretty similar, and it should be straightforward for anyone to determine what's really going on within their test case. Okay? So, and here we have a typical API test case in Tricentis Tosca. The actual definition of the web service on the left-hand side we have may look a bit frightening and technical, but if you look at the test case itself, it still should be possible for anyone to get the idea of what is done here. Now let's put the API test and the UI test side by side. Don't they look almost the same? Seriously, both are just another abstraction layer in a human-readable form for our application and the test. Bottom line is, as a test engineer, you should not step away of the idea of creating API test cases just because you think it's a technical task that can only be done by developers. Tricentis Tasker provides you an easy-to-use interface that allows you to create, run, and maintain your test cases, no matter which technology, or if it is UI-based or non-UI, they always look basically the same. So we've seen in the chart initially that manual testing will almost vanish, but a certain part will still remain. So what will that look like? We talked about automation, but there seems to be still some manual testing. What will it look like? Let's pretend this is our system landscape, and throughout our environment, issues appear here and there, which leads to certain areas with risk that potentially should be covered by testing. That could be performance issues, usability issues, security issues, you name it. So with our automated regression tests, we are now mainly doing specification-based testing. What do I mean with that? Basically, it means we have a certain baseline or expected behavior of our application, and we check if the actual behavior matches our expectations. With this approach, we can cover a certain amount of risk areas, sure, but as we have already mentioned, we cannot test all the risks exhaustively because of, for example, time or budget constraints. This is the gray circle which represents the specification-based testing. So basically our automated regression tests we run on a regular basis. This leaves us with quite some risky areas uncovered, right? Partially because we have not enough resources to cover, but partially also because we simply don't know these areas. And this is where exploratory testing now kicks in. In contrast to specification-based testing, the tester here is equipped with a testing charter, which basically states the area to focus on within the application. And all the rest, the path through the app, the tester will take, the details she will focus on are up to the tester's creativity and curiosity, which makes exploratory testing the perfect addition to specification-based regression testing, as it covers risks you would never have on your radar otherwise. Therefore, for us at Tricentis, we call it the Agile testing law, which is basically an equation which says properly tested is an equation of checked via automated regression tests plus explored through exploratory testing. That's it basically from my side. With that, I want to hand over to Sarah again.
Great, thanks so much, Thomas, and thank you, Siva, as well. And at this time, we would like to get your questions answered. And as a reminder, you can at any time just ask a question in the Q&A window at the center of your screen. Pulling up the first question here. Thomas, I believe this one's for you. Does your offering work for microservice or middle architectures?
Very good question. IT world is moving forward fast. We see that. We have microservices, we have containers and cloud native architecture. That's all on the rise. But still, classic middleware has its right to exist. We know that. So we are aware of the need to virtualize both architectures, which is why we support the test and virtualization of all kinds of API gateways and enterprise service bus implementations. So long story short, yes, we support both.
Great, thank you. And then Siva, here's a question for you. We have automation that needs to be run against multiple test environments. How do you manage the test data for each environment?
Okay, yeah, so this is also a good question. So this is with automation that needs to run against multiple environments, right? So we see this as a constant challenge because you end up running, you may have to run the same automation against the development environment and also run against multiple QA environments, and also even to take it to the extent of running against the production environment also, right? So the approach, the recommendation, or what we have seen working if you have a situation that you need to run your automation against multiple environments, the way the framework needs to be capable enough to kind of pick and choose what test data that you want to use. And there are also concepts available for like the test data manager, where the tools would allow you to kind of dynamically create the data based on the environment that you want to run, or the automation framework, or even Tricentis also supports the task suite that we use for many of our engagement, and other automation tools that I have personally used does support data-driven approach. So you want to make sure that the framework that you use, or if you end up developing something in-house, ensure that there is an opportunity or option to kind of data drive the entire automation, so that you can pick and choose what the test data that you want to use, or if there isn't, even to the extent you want to go and use the service visualization, or have the concepts like the test data manager that would allow you to create the necessary test data on the fly based on the environment that you run. Right.
Perfect. Thanks for sharing, Siva. Actually, and another question for you, Siva. What are the challenges in adopting in-sprint automation, and how do we overcome them?
Okay, so this is kind of one of the this is an ongoing improvement that we see. There are multiple solutions available. Again, this is we kind of, it varies or depending on your particular need, because the in-sprint automation requires a lot of coordination between team that you end up working with, right? For example, in some of the implementation, we did kind of a handshake with the development team that you want to have certain object properties. You want to have it defined, and there is a good understanding between the development team and the automation team. When you start writing the automation, you want to make sure that you are using those specific properties, and the development also has an understanding that they don't change certain properties, because that is one way to achieve the in-sprint automation, or kind of at least reduce the risk of the test automation scripts going out of sync, right? The other thing that we have seen that kind of worked out well for in-sprint automation is you want to start your automation like we discussed in today's session, that you want to start your automation at the code level as much as possible, and have that being used by the development team also, right? So that way you are kind of increasing the reusability. At the same time, you are also kind of validating the scripts that is working at the development environment also, so that if there are any failures, you are able to kind of get to know well in advance, right? So these are 2-3 techniques, but there are quite a few options available. We'll be happy to kind of share if someone has any specific interest in knowing more about on this particular problem.
Great, thanks so much, Siva. Thomas, question for you, actually a couple. Someone mentioned, how do I get started with API testing? I understood that Tricentis provides an easy way to create and maintain tests based on APIs, but where do I get the specifications for my test? I have my user interface in front of me, so how do I know which services are underneath?
Thanks, Sarah. Interesting question as well, sure. We talked about it. We've seen that so far API testing has been a developer-only topic. Yes, it's true. We try to change that. So with Tricentis Tasker, we now try to really shift this to business testing. And in a world of DevOps, where DevOps is really the most important focus on, I would say it's an excellent possibility to get now really devs and test engineers closer to each other. So bottom line, to start with, get in touch with your devs and ask them for possible endpoints you want to check towards. They will be happy to support you with that, because they get rid of certain tasks like API testing, if you can take that over. Besides that, we are already working on a kind of auto discovery functionality that will make it even easier for you to directly extract API tests out of your existing UI test cases. So stay tuned on that.
All right, great. Thanks, Thomas. And I believe we have time for one more question. Siva, I think this one's for you. I like the pyramid approach that you showed in your presentation. Are there any open source frameworks that support automation of these different layers?
Yeah, so no, this is a good question. So we, like I've been working with many enterprises and mid-sized companies as well. We see there is a lot of innovation happening on the open source technology also. In, I think one of the slides you might have seen that one of the success factor also to kind of how we can leverage the open source technology. It comes with its own caveats, right? So certain tools may or may not have the right support. So that's why we recommend, depending on what is your need, to leverage products like Tosca or other solution. But to answer your question, yes, there are like open source solutions available. In fact, InfoStretch also has an open source framework called Community Automation Framework. We'll be happy to kind of share. So many of the framework does support the pyramid approach, right? What it means is that you will be able to use the same framework for automating the unit test as well as to the UI test, right? So in between the entire pyramid layer that you saw, you will be able to use framework like open source framework like Community Automation Framework. You will be able to use that to automate the various layers, right? So that not only helps you to kind of reuse the test asset that you build across the layers, but also helps you from the overall organization perspective. Your learning is kind of reduced to one specific tool set in terms of the standards or in terms of the reporting. All that is kind of made it to single framework, right? So that's the benefit you get. But there are quite a few other frameworks available that support the entire pyramid structure that you need, along with the commercial tools as well.
Perfect. Thanks so much, Siva. And I believe that's all the questions we are able to answer at this time. Be sure to check out and subscribe to DTV. It's a new digital transformation channel that brings in industry experts. Very cool. Many thanks to our speakers, and thank you everyone for joining us today. You'll receive an email in the next 24 hours with the slide presentation and link to the webcast replay. And if you have any questions, please contact us at info@infostretch.com or call 1-408-727-1100 to speak with a representative. Thanks again, and enjoy the rest of your day.